Hi, my name is Antijoin, and I'm a data scientist. So I'll continue to build on your knowledge. If this is your first time, you may need to watch some of the videos that I've done, Introduction to R100 and 101. So this is now Introduction to R103, right? So just make sure that you have seen those videos. We have covered this. So if you're a beginner, for you to work with R, I need to install some packages and install R. I'm going to leave a link in the video where you can download R if you don't have R as yet. Then you can also follow my videos as well. So in the last video, we covered some libraries, and I think it's important for me to just remind you that you use library here to tell R that my libraries are in this project file. Then you also have got library read R, which is powerful for and very fast for importing data sets into R. Then you have library dplyr for data manipulation. Then you have library ggplot for data visualization. It draws very beautiful data diagrams. Okay, so we I'll continue to build on your knowledge on importing data, right? Because so let's say you want to import this file, right? What we can do is simply saying, I can say path is equals to, I copy this is the path to my file. I've already done this in the previous video, but when you want to automate, I remember when I wanted to automate a process flow, this is what I had to do, right? I wanted to write a function that imports data automatically. So I just had to change a few things, right? So if I say path is equal to this, you see here that I now have got a new argument in my script which is saying values. Okay, let's remove this. Let's remove everything so that you can see, right? So I'm going to import my libraries. My libraries have loaded well. So I'm going to say path. I've got a path values. I've got this item that I've created. So I'm going to use this item now to tell read CSV, which is a function in R, right? Which we path. So once I do this, R is able to pick it up, right? To say I'm supposed to follow this. So this is how automation begins. You see, when you start to chain a lot of things, you will not understand what's going on. But hey, I just wanted to let you know that what is a path and how we can manipulate it. Okay, so that's my data set that's downloading there, and it's now showing me that hey, there's a new object that you have downloaded, and it's like this. Let me show you, maximize my screen to show you. This is what we have done using the path and read this CSV. Okay, so let's I'm going to delete this. Let's import our data sets. Then you remember we've got mainly three data types: the numeric data, the date and date time objects, text. We are going to do a course called working with dates and times in R, where we are going to show you how you can do something that's very powerful, like creating models, time series analysis. It's very powerful. You don't want to miss that out. Then this basic data exploration, we covered that, where you are looking at how your data is like structured, right? So the rows, the column, you can also use it to access values in a data set using these commands, the rows and the columns. Then summary, your glimpse, don't forget those. Your view, we covered that. So the filter functions, we covered filter, we covered arrange. You can pause and look at the codes if you want and try to run them if this is your first time, but those the arrange, and you say that minus will mean that we want it in reverse order. The default is ascending. Then we also did arrange plus filter, which is now chaining methods, and we saw how powerful it was. Then I introduced you to in and the pipe operator. We said if you've got multiple arguments that you want to pass in a single column, you now need in. You don't use a comma, don't forget that, or you can use or, right? Then we also covered mutate, where we said if you want to create new variables, what you then need to do is to say to use mute function. Then we also saw that mutate is very powerful when you want to convert data types. Sometimes when you import a data or when you get data, the data could be wrongly coded, or upon importing the data, it could be interpreted wrongly. So you may want to change that to numeric, or to date, or to character values, or in R there are actually what you call factors. You're going to do factor analyzing factor data, or analyzing categorical data in R. We're going to cover that as well. So here I was doing a mutate and I was changing this to numeric so that you can make computations. Okay, so let's move filter, mutate. It becomes very powerful, like I said, when you start to change these methods. And you have, let's suppose you have got you use select, you use filter, you use arrange, and you use mutate. Then it becomes, the analysis becomes very mature, and among other things, summarize, which you saw in the last previous video as well. So these are the important shortcuts that you need to know: the pipe operator, control shift M, script control 1, control 2, move to console, then your new section, control shift R, then run code. Of course, you need to know your outer enter or control enter, right? So we saw the summarize function last week, and we also saw the mean, the max, the product, the median, the variation, and the standard deviation. So today we are doing lesson 2. We are going to pay more attention on grouping data, right? And we actually did a bit of this last time for those who were with me, but we are going to look at grouping data. So oftentimes in business, in industry, in manufacturing, we want to see results of group together. Let's say this is a car manufacturing industry. I know there's the MT cars dataset, which is very popular. You want to look at Mercedes-Benz only and compare it with how it is performing with Tesla, and you want to look at Mazda, Toyota, and compare. So that's where grouping comes in, to say, oh, okay, hey, in this data set, I want you to group by the company, then give me a summary of whatever, right? So we see here that, what is going on here? I'm going to break this code down so that you can see what's going on bit by bit, right? Okay, so first we've got this flies dataset. Let me increase here, and maybe here, I think you can see better. I'm not using this part, so I'm going to also increase it like that, right? Okay, fine. So let's move that upwards a bit. It's the same code. All right, so let's, if I say flies dataset, this is the dataset that we have, right? I'm sure you all know that, which has got which has got 14 columns and 336,000 observations, right? So if I say I want to run this code to say, if I say flies grouped by the carrier and origin, right? What does it mean? Let's have a look at our flies dataset. So we're going to say view flies, right? So if we do that, we view flies, you're going to see this is the flies dataset, right? You've got year, month, day, dates, departure time, scheduled time, arrival time, scheduled arrival time, carrier flight, the tail number, which denotes the tail of the flight, then the origin and the destination, the arrival time, the air time, how much time was taken when the flight was in the air, and then the distance, right? So let's go back to our code. So if I say, so I was saying, I'm going to remove this, so that, because I'm going to give you these scripts. So if I say group by the carrier and the origin, what ARA will do, it will first group the data set using the carrier, then after that it will group using the origin. So let's view that. Okay, so we see here that let me brush this. And run it again. Okay, so there's a grouping that has happened there. I can see the carrier column. You can see that for 2013 we have got UA and UA. There are 35 groups has been created based on origin and carrier, right? So when I say summarize now flights, I'm adding a pipe and give me the number. See what will happen. This becomes very powerful. You can see the carrier right here, and then you can see the origin and the number of flights, right? So I'm going to chain and add a pipe. Then I'm going to say, okay, give me um, the count, compute the flight count and percentage of each carrier out of each airport. So for us to compute the percentage of carrier, what you are going to say is you're going to say, okay, number of flights, which you have calculated here, the number of flights, right, divided by the sum of flights, which is the total of all those flights. You get it, right? So this can be done using this very simple code, right? And this is what we're going, this is our end result. So in the end, we have a new column. We have created two new columns, the number of flights for each carrier and for each origin. Then what we've also done is we have also went further to calculate the percentage of each flight. So that's how powerful ARA is. And you remember from the previous exercise, I was trying to show you this line of code where I was saying summarize is also creates new variables, and you can then name your variables using in place you can directly name your variables. This is what is happening there with the number of flights is equals to n. So we can let's suppose we change it to just n and run this to just n and run. Let's rerun the code. Okay, so I'll need to change a lot of things in many places. I also need to change this part of the code and this part of code. So if I run this time, you're going to see that we are going to get the same result, and we have got n here. So that's basically what I wanted to show you, that hey, summarize can be used to create new variables. And the mutate, we covered it last time, where we saying we also create a new variable called percentage of flights, which is equals to 100 times number of flights, so that we get the percentage over the sum of flights. So let's proceed and look at this one. I'm going to delete this. Then what is changed from the previous code is that I've assigned this to a, which means I've created a new table called carrier origin, which I'm going to store the result and send this report to a manager to say, okay, this is the summary statistics. Or if I was creating a system, then this would be what the will be showing on displaying on the system, right? I can just then show this on the system, right? So we have got this one where we're saying carrier origin summarized total percentage is equals to some um some some percentage flights. Okay, let's do this, create this variable. So this is what I was trying to tell you the other time, that when you group when you group a variable, you need to ungroup it later on, because what you can see here is showing 100, but that's not what you really want. You wanted maybe to get the percentage of each item. So yeah, just remember that about grouping. Then let's proceed to the next one. We are saying we want to arrange this new object that you have created called carrier origin. We are going to arrange it using the carrier, and then we want the number of flights in descending order. So let's run that code. So what we then see is that we have got carrier arranged by carrier. So we see that 9E9 E9 EAA8 has been arranged. Then we also look that we can also see that because carrier here is the last grouping item, you see that it takes precedence over the other items. It first grouped by the origin to say the groups were JFK, La Gondola, and EWS. But then you also see for each flights how it's playing out, right? So compute the flight percentage of all flights out of each airport operated by each carrier, right? So we do the grouping. This is what we have already covered this part. So we have got our n flights and percentage of flights. Then let's look at another one. Compute count and overall percentage of flights operated by each carrier out of each airport. So this is a very complicated query, but you see it's becoming very powerful. It's very good for management. So we start with the flights data set, then we group by the carrier and the origin, then we summarize, and then what we're just doing in the summarize, like I said, you're saying number of flights, you're creating a new variable called number of flights, which is a summary of carriers and origin. After that, we ungroup, what I was talking about, that after grouping, and if you want to continue working on the same data set, you need to ungroup it, right? Because if you don't ungroup it, you remember those 100% which I just showed you just a few minutes ago. So after that, we use our mutate. We are mutating. We are saying mutate. We are creating a new variable called percentage flights, and this is what you have done, and you have arranged in descending order. So after doing this, if we run this code, we are going to see that this has now been arranged, and we are seeing that most flights they're originating from UA, right? And then maybe the next one was EV, then it was B6, and they were going. The origin was the carrier was United Arab Emirates. Then it was originating from EWR, right? So that's it. Or alternatively, what you can do, you can save this variable, right? After saving the variable, you can then compute it further and arrange it further, right? That's something that you can also consider doing. Then compute the flights and overall percentage of all flights out of each airport operated by each carrier, right? So we are just doing the same here, right? So these are some of the powerful summary statistics that you can see, and that, well, you can then use to put to show on your dashboard. Then this the other verb that I did not discuss about previously was the select verb, right? We use select for selecting specific columns. And if you, as you can see here, I've got the flights and I'm saying select year, month and day. If I run this code, it's just going to give me a subset of those it's just going to retain only those columns. So if I was creating like a system, right, a pipeline, I could which needs to have like these data sets for a department or a manager. That's what they now then do, and then extend it further to do other items, right? So if I say select minus r minus, if I put a minus whenever I use a minus before a variable, what it then means, like uh, here specifying columns we don't want. You see that I'm saying flights select minus arrival time minus k. It's going to remove these columns from the selection. That's what minus is doing. Remember, we've used minus before. If this was arranged, what you then mean is that you want the opposite. So minus is used to negate, the behavior of a function. So we can also select like a sequence of item or a range, where we are saying select department time up to origin. That's what this select function is doing, and it will just pick those columns. And if I say select minus that range, it means that I'm also saying, hey, select negate this range, I'll get the remainder, which tends to be fast. And also that's how we just start automating things. Then we've got what we call select helper functions, like contains. If I say select contains time, well, let me show you how this will behave. It's going to pick all columns that have got time, like department, arrival time, and all this time. So if you were doing like some, just it was huge, like suppose it had 500 columns, 200 columns, you you tend to need these helper functions, right? So I'm saying select contains time minus a time, which means that I'm saying select all this but remove a time. Let's proceed. So just follow where I'll be discussing where my mouse is, right? So select contains time, then also put a range. It retains that. Then you can also use select matches time, right? Let's see what this one will retain, right? But it's just the same. It will just pick only where there is time. You're using match as your helper function. Then select columns that start or end with a specific string of characters. You can use select start with depth, and it will pick the departure time, right? So if I run this code, you see that what you actually see is that we have this column which saying departure time. Then you can select starts with, it just behaves the same. Then ends with, if I say select ends with, as you can have guessed, it just gives us what the last item. It will just pull out the column which ends with time, right? So let's run the code, and we see that again we have got that. Then we've got another powerful item, a helper function called everything. It's useful for arranging objects, right? So when you have got your flights, we are saying select airtime, origin, airtime, distance, and everything. So what it then does, let's say your manager or your boss wants to see like your items arranged in a certain order. So you may need to start with origin, airtime, and distance, and keep everything else, because you are not going to really look at those columns in your analysis. So that's what you may need to do, right? Then you can also use minus to negate, like in this case you're saying select origin, distance, everything, right? Then I say minus contains time. So if you do let me explain some items, some mistakes that starters do. You would then say if you do this, it says origin distance minus contains time, then everything. If I run this code, you see that here I've got a table with 9 columns, right? But when I run this code, I have got a table with 14 columns, right? So don't do this. What you need to put your everything first, then if you want to remove some observations, you then put them at the end, right? So just remember this, that don't do this. I'm just going to say don't do this, don't do this. Yeah. Then while we are going deep into our analysis, and we've got a function called case1, which is very powerful when you want to analyze multiple conditions, right? So here I'm saying flight, which is my data set, select the distance. So what this then does is going to pull out, I'm going to remain with one column for my analysis, right? Which is the distance column. As you can see, we now have got one column, and which is the distance column. And I'm saying mutate, which is saying create a new column called distance label, right? And I'm going to create new labels, right? So case1, I'll then call the case1 function to say case1 the distance is less than or equals, right? Then call that close. So case1, in this case, the tilde functions, what follows after the tilde function is the naming conventions, right? So then I say distance when distance when distance is greater than 500 and distance is less than or equal to 200, then this is fairly close. When distance is greater than or equals to 2000 and distance, this is fair. And when distance is greater than, so what we are doing is we are splitting the flight distance into 4 categories. Then if we run this code, right, if we run this code, we are going to get the summary. So I remember I was doing this, I was working in this other department, and they had this Excel sheet that they had this sort of analysis where they were saying, okay, I think they were doing some aging, they were calculating aging, and they were looking for 0 to 30 days, 30 to 60 days, 60 to something days. So this is how you can automate the whole pipeline, right? Using that, if you find yourself when you want to categorize data, this is, you can use the case1. Then split temperature into 4 categories. Again, we are using the case1 to create this. So don't forget your tilde, and you can also use the end function and your greater than and your item. Then after that, we then said group by code level, and summarize n is equals to n. Let's run this code. I'll explain the code after running this code, right? So what we did here is we then said, okay, after creating this table, right, I want a summary of temperature, but that has been grouped by the code level, and give me a summary of the numbers of how many are in each of those, right? So that then that is the result of the temperature, to say, okay, the temperature, we have got variable temperature, this is the number of observations. So as you can see, if I'm going to create a dashboard, these are the sort of results that the managers will sort of need. Then yeah, we can split temperatures into 2 categories. We can use the if else function also, yeah. So we've got an if else function in Excel. We've got those functions, the if function, which you can chain. We can have also else in Excel. These are the logical operators. But as you can see in R, it becomes very intuitive. Like I can look at all the codes that I have run You know, if I look at my console, I'm at my console right below. I'm just trying to show you how this is become powerful. Then I can also look at my commands, right? If I can say the last commands, this is the before that, what was I doing? So I can then look back and run the same command if I wanted to, if there was need to do that. That's why you need to learn programming and to be able to do this on your own. Right. So we're saying select split temperatures into two categories: weather, select temperature, mutate code level. Case when the temperature is greater than 70 and the temperature is less than life is good. Then comma true tilde life is good. So what the true is doing is saying else, you know, else just saying okay, life is good. We're just interested in this observation, and everything else just throw it. That we could have said other is one popular item that you can see in many analysis, right? Then so we have got select code level. If else temperature is greater than 70 and temperature is life is good, then everything else will be thrown into the life is not good variable. Then conditions here are based on two variables. So we have got the weather, select temperature and wind speed. So we've picked two variables, and we are saying mutate code status. If else temperature is that, then code. If not, not code. Then wind status, we are creating a new column called wind status. And if else the wind is greater than 16, say it's windy, and if not, not windy. Then state of life, case when we have used case when as well. We've used these methods together, but they just do the same as you can see. Then of course we have thrown the rest in true, it's okay, right? Which will cater for those conditions that would not have like captured, right? Okay, so let's run this code and see how powerful what we have created, right? Like, so we have created this state of life, the wind status, and the code status. Just with the simple codes, we're able to create this powerful analysis. So this is really big. And I think at this point, if you listen to my video, and then we are going to revise a lot as we are doing specific courses. Like we are saying, one day we are looking at categorical variables. I'll be chaining all those things. If you revise your data science with R101 or data science with R102, you are going to see that these are things that will be recurring, right? Then of course, as a parting note, I'm going to introduce you to joins. Joins are very powerful, and I'm actually going to, after this video, I'll do a course on joins. But I just thought that it would be nice to just do touch on joins in this introductory video, so that when we have time for questions and answering, and then obviously you'll be comforted, you have an appreciation of what R does. So I've got this type of joins that we have. We've got the full join. We've got full join. We've got partial joins, right? Broadly, that's what we have. But we will then say, okay, we've got semi joins as well. Then you have got antijoin. Yeah, those are the yeah. Then you have got of course the right join, the left join. Those are some of the joins that are really popular. But of all these joins, we'll start with the left join, right? So when you look at the left join, in this case, you're saying in the flights data set, in the planes data set. Let's have a look at this. We've got the flights data sets here, which has got 14 columns, right? then we want to look for something that we can use to join these two tables together. So in this case, right, we can then use let me close this file so that we just focus on the two. We are looking for a common identifier. This is the plain data set. We can see that there is tail number. I think in the flight there is tail number as well. So there's tail number, this column, and this tail number. So this is the column that we can use to join these two data sets together, right? So we are saying left join. If you do a left join, what will happen is you are saying keep everything in the flight data sets, right, based on the match that you've got a match in the plain dataset. That's what left join is doing. Then you are saying summarize, then sum seats na.rm equals to true. We have covered this. We are saying remove all those blank variables. So let's run our code. We can see that the total passengers were 38 million. Okay, so what we've just added the summary here to just add a level of complexity and to just demonstrate the power of chaining functions and doing other things, right? So let's proceed. Which carrier transported the most passengers in December, right? So this problem would want you to look at the carriers which you can find in the flight dataset. Then it also needs you to look at the passengers which you can compute using, the seats. Okay, then December, which is a date object which you can compute using the month argument. You remember, and there is a column called month which is denoted by 12, right? So if we select the months, the carrier, and the tail number, those are the columns that are interested, and then we filter for the month is equals to 10. Then we perform a left join to the plain dataset by the tail number, because in the plain datasets when we want the seats which are not available in the flight datasets. Then we count the carrier, then we put the weights on the seats, then we sort in so that we have got our data is logical. Then we give a name equals to passengers for what? For the count for the new object that is going to be created. So that's it. As you can see, we have got our data set arranged, right, and it has been sorted, and we can see that the variables are in descending order, right? Then we have got which planes are not used to fly people out of New York. Okay, if you have stayed here for this video long, I want to be very honest with you. I have done some analysis, and I've used an Antijoin where people were doing, I don't know, spending 30 minutes, 40 minutes doing an analysis. But I've just said, okay, comparing two data sets, I've just used this Antijoin. What an Antijoin is also called a filtering join. What it does is you take two data sets and it just shows you what's in plain data sets that's not in the flight data set, right? So that will be your Antijoin, right? So if you look, it usually shows you it retains very few arguments, right? So which planes were not used to fly people out of New York? So you see that it retains 0 there. Were there illegal flights out of New York? So we can then say flights planes by equals to tail number, select carrier and tail number, distinct tail number, carrier and tail number, count carrier sort equals to true. Okay. So for the purpose of this video, well, I'm not going to dive deep into this analysis. I'm going to explain this code more further why we had to look for the flights that were illegal, because I remember when you're doing this with Professor Guguneno, we picked that the data sets had some interesting observations about the flight, but it's going to make this video very long. So for now, it's just enough to know that the Antijoin is powerful, and then it can be used to see which observations are not there that are found in another dataset, right? So this brings us to the end of this course. Then in the next video we are going to work on this certification course, where we are actually going to do work on preparing you to do your certification course, because you now know a lot of things, guys. So bye for now, until we do the next video, which is data science with R